All right, this is part two. I'm trying making, have you guys had that pretzel dessert? I don't know, with strawberries and cream cheese. Tried making the crunchies on top instead of on the bottom with Jello, but I don't know, it didn't turn out very well. So I think I messed it up. So now I'm trying to make it again. So lovely. All right, let's get back to math. Okay, let's finish up. All right. So remember, most of trig is either unit circle or something that it may be something you have memorized, or at least you can draw it on the unit circle. The other problems are bow tie, right? I mean, that's most of things. A few things are on the calculator, a few things are identities, things like that. But I'd say 40%, 40%. All right. So let's look at this. Remember, trig functions eat an angle. Okay, so we're at an angle now. Again, if I cut pi into 20 pieces, 21 would be barely over there. So this is going to eat the angle. This guy is going to spit out a ratio. And then the inverse function is going to eat that ratio for input, or have it as input, spit out output. Okay, so let's see. Tangent is what? Positive over here because I have a negative divided by a negative, right? Both ratios are negative here. All right, so I'm going to get a positive. Now, inverse tangent is, where is that defined? Inverse tangent is on this side, and no inverse functions are defined here ever. So again, if you think of your unit circle, if it's sine or cosine, you might have to reflect up, or you might have to reflect over if you're over here. But tangent reflects across because this has a tangent of +1, so does this guy. So let's see. So whatever this tangent is, it's positive. Obviously, it's not at a 45. So I'm going to slide that angle over here. And notice if this is what? This is just a pi over 20 down because this is 20 pi over 20, right? 20 pi over 20 would land on the 180, and then just another pi over 20. So this angle over here, my final answer, it's going to eat in a ratio, spit on angle. That angle is going to be pi over 20. All right, let's look at the next one. Okay, so this guy is going to eat an angle. Okay, again, these are on the unit circle. They're just things we don't memorize. If I cut this into 9 pieces, this would be 9 out of 9. Sorry about that. All right, so 8 pi over 9 would be about there. I'm going to mute my phone here. All right, so again, what do I have? I have a negative and a positive, right? I'm going back and up. So sine is going to have an input of an angle. All of this is going to spit out a ratio. Okay, so it's going to spit out some ratio. I don't know what the ratio is because it's not one I have memorized on the unit circle. We don't do that one. Okay, so inverse sine, though, is on the side. And notice this is not where I want it. So again, tangents go across, but like cosines and sines, we reflect across or over, because you can see, you know, they have similar, like square root of 3 over 2 is positive here for sine. So is it there? Sine is positive. Same here, positive half, same here. So with sine, I could maybe reflect this way. All right, so what am I doing? I am doing sine, and I want this positive ratio to be the same. So I'm going to reflect it over here because inverse sine is defined. Now I know it's positive, positive, but I don't care about cosine, right? I'm only doing sine, so that's the only thing that matters. All right, so let's look. So this was 8 pi over 9. So I know this little sliver was pi over 9 because this is 8 pi over 9 to there. So pi over 9 is going to match over here. So that's going to be pi over 9. All right, next one. Okay, this time my inverse function is going to eat or have an input of a ratio, and it's going to spit an angle. This guy is going to take that angle, whatever it is, and my final answer is going to be some type of ratio. So this is a bow tie problem, right? Because I want a ratio ultimately. All right, so let's make well, I don't know why I did that. Let's make an XY axis. Okay. So I'm going to put a -5. I'm going to put a 1 under there. So SOHCAHTOA, so opposite TOA over adjacent. Okay, now inverse tangent, where is it defined? All right, it is on the side. So these two are out, right? They're not even options here. And so I want a negative. So I'm going to draw my bow tie down here because it's not positive. Tangent is here. Okay, so SOHCAHTOA. Opposite is -5. That makes sense. The vector is going down there. Adjacent is going to be 1, and I know this is not to scale. All right, Pythagorean theorem. I know A and B. I don't know C, so this is not a subtract kind. This is an add kind. So I get 1 plus 25 is 26. Square root, so this guy is square root of 26. All right, so now what? Okay, so there's some angle theta here. I know it's there. I don't know what it is. The tangent is going to eat that angle and spit out the ratio. Okay, so what's the tangent of that angle? SOHCAHTOA, opposite over adjacent. I'm going to get back to where I'm at. Now, does it always work? No, you can't just always cancel these. Why can I this time? The reason is because I'm in an area that's defined by both tangent and inverse tangent. Are you guys okay if that was up here? If the bow tie was up here, all right, then we would, well, it can't be because the inverse tangent limited to begin with. If I turn the order around, then the angle would change too. So yeah, not so much. But again, don't always think they're going to cancel. Like up here, do you see how the sine and inverse sine do not cancel and give you the right answer? Cotangent, tangent do not cancel and give you the right answer. So just draw it out, look at it, see what's going on. All right, let's do this one for our last one. All right, sine of 150. We haven't done a lot with degrees. Okay, so this is what, 90? And this is what, another 60, which is great because that's on the unit circle, right? So if you look at sine of 150 on your unit circle, you would be like, oh, okay, so let's see, I'm what? Back square root of 3 over 2 and up a half. Okay, so now what happens? The sine is going to eat the angle or input of angle, and it's going to spit out the ratio. So it's going to spit out the ratio of what? On the positive half. The inverse cosine is going to eat that angle now, or that ratio, sorry, and spit out an angle. So, but again, inverse cosine is only on the cap, right? So you're going to only look at the cap, and you're going to be like, okay, when is cosine what? A positive half? So cosine is a positive half right here, and that would be 60 degrees, okay? So that one's going to be 60 degrees. All right, hopefully that helps you. Basically, just know, kind of keeping track of what things do, right? Like cosine, sine, tangent, they eat angles, and their job is to spit out a ratio. And then inverse functions eat ratios or have an input of ratios. They spit out angles, okay? And again, if it's something like, if you see square root of 2 over 2, square root of 3 over 2, a half, those are on the unit circle. So you can probably just look at your unit circle and get those. If it's something like, you know, inverse sine of, you know, like say 3 over 7, that is not on the unit circle. So you're probably going to have to do a bow tie so that you can answer, like, do this part and then do whatever's on the outside, like cosine of that, okay? If it's an angle that you don't know, so say you have, you know, sine of whatever, 211 degrees, and you're like, well, you know, technically it's on the unit circle, but you don't know what it is. But again, you can draw a picture, you know, and maybe, you know, figure out a few things, right? Okay, maybe not that one. That would eat an angle, spit out a ratio. Yeah, you could figure that one out. Okay, so a lot of it's very visual and just kind of knowing what to expect. All right, good luck. If you need more videos, let me know.